now factoring special cases, which means like just by looking at it, you can factor it without doing this casual or the box method. And let's start with the first example. If we have x squared minus 12x plus 36. Now, do you remember the first thing that we said? That we have to, whenever we have an equation, we have to look at the first term and the last term. Are they perfect squares? Yes. X squared and 36 are actually perfect squares. And to do the factoring for them, what is the square root of x squared? It's x. What's the square root of 36? It's 6. Now, it should be positive, of course. Now, we'll ask ourselves, is 2 times 6 times x is 12? Yes, 2 times 6 is 12. 12 times x is 12x, so it is a perfect square. So what do? Is we open a bracket, we put the square root, the square sign, sorry, and we write the x here, 6 here. Now we have to know what's the sign. Since this positive, again, it means that the numbers, they're negative or both positive. What determines is the b sign. It's negative, so this is a negative sign. X times x is x squared. 6 times 6 is 36. 2 times minus 6 is minus 12. Negative 12 times x is negative 12x. So our solution is correct. If you forgot what a perfect square is, a perfect square is a number that is actually the product of a number multiplied by itself. So positive 36 is actually 6 times 6. 25 is 5 times 5. Of course, this should be positive because we cannot get a perfect square for a negative number because, for example, negative 36 is 6 times negative 6. Those two numbers are not the same, so negative number, it cannot be a perfect square. Now let's move on to variables. X squared is, well, let's do 9 so you can see the difference. 9 is 3 times 3. Now for variables, x squared is x times x. X to the power of 4 is x to power of 2 times x to the power of 2. Remember when we said we have the same variable with a multiplication in between, we actually add the exponents. So 2 plus 2 is 4. This means that x to the power of 9, for example, is not a perfect square because we don't have any two numbers. If we add them together, will give us 9, that they are the same. It's either 4 and 5 or 7 and 2, which means those two are not the same. So in case of variables, a perfect square in a variable is actually a variable that has an even exponent. It's like 8 as a number is not a perfect square, but x to the power of 8, since 8 is an even number, is a perfect square because it's x to the power of 4 times x to the power of 4. Hence 4 plus 4 is 8. Now let's go back to factoring and have another example. If we have 27 x squared plus 90x plus 75. If you remember from a previous example, we said we look at the numbers, they're not perfect squares, and then we say, can we take a number out that will make it like easier for us or can make it a perfect square? And the answer is yes, because 27, 90 and 75, they are all divisible by 3, so we can take 3 out. 27 divided by 3 is 9, x squared plus 30x plus 75 divided by 3 is 25. We'll ask ourselves, is 9x squared a perfect square? It's yes. Is 25 a perfect square? It's yes. So now let's factor this one. We put, what is the square root of 9? It's 3. For x squared, it's x. For 25, it's 5. Let's test. Is 2 times this give us this. 2 times 5 is 10. 10 times 3 is 30. So the answer is yes. Please don't forget that we have a 3 here. So we put 3, we put the bracket and a square. 3x and 5, and the sign is the sign in the middle, which is plus. Let's have another case of special cases, which is the difference between two squares. An example is like bp square minus 36. P is a perfect square, 36 is a perfect square, and we have a negative in between, which means it is the difference between two perfect squares. Please, it is a difference. It's not the addition, because we will learn that if it was a positive sign, this is cannot be factored. Okay, so what is this? In this situation, we have actually two factors. What is the square root of p times p? 36 is actually 6 times 6. Now one is negative, the other one is positive. If you ask me why, try to multiply them and you will find out that we're gonna have this one. Let's examine that. P times p is p squared. Minus 6 plus 6 is minus 36. Now let's do the one in the middle. We have minus 6p plus 6p. Those are 0, so it will leave us with p squared minus 36. Mathematicians, they multiplied a lot of a number to factors that they only differ by the sign in the middle, and they always found out that it's the first one squared minus the second one squared. Let's have another example on the difference between two perfect squares. We have, for example, 9n square minus 400. This is a perfect square. It's 3n, and this is actually 20. So we'll open two brackets, 3n times 3n, 20, 20. One is positive, the other one is negative. The last example in this one. What if we have, for example, 27n to the power of 4 minus let's say 27. We have a difference, but they're not perfect squares, but we can get a greatest common factor out, which is 27. So let's take it out. N to the power of 4 minus 1. Now 1 is a perfect square, and to the power of 4 is a perfect square. Please don't forget that we have 27. So we'll have 27 n to the power of 2 minus 1 n to the power of 2 plus 1. If you remember, this is a perfect square, this is a perfect square, but they have plus, which means we cannot factor it. But if we look at this one, actually we have n to the power of 2 is a perfect square, 1 is a perfect square, and we have a negative sign, which means we can factor this again, because we are not when you factor, you have to factor to the ends. So we have 27. Again, this one, we can factor it as n minus 1 times n plus 1. Remember, this is the factoring of this one, and this one is actually non-factorable, so it's n plus 1. Again, in this situation, we had 27n squared minus 27. 27 was a greatest common factor, so we took it out to find out that we have n to the power of 4 minus 1. Now, n to the power of 4, since we have an even exponent, it means it is a perfect square. 1 is a perfect square. We have a negative sign in the middle, which means it's factorable. Don't forget that we have 27. n to the power of 4 minus 1 is a special case, which means it's n to the power of 2 minus 1, n to the power of 2 plus 1. Now, n to the power of 2 plus 1, although both of them are perfect squares, but having a plus sign or a positive sign in the middle, it's non-factorable. So we look at this one, we can factor it again because we have a perfect square, and a negative sign in the middle. And that's what we did. N to the power of 2 is actually n times n. 1 is 1 times 1. 1 is negative, 1 is positive. And this is factoring till the end. Remember always that you have to always factor everything till the end to have parentheses that are non-factorable.